Chillon River originates in the Chucho and Chonta lakes at an altitude of 4,850 meters above sea level and has a length of 126 kilometers with an average gradient of 3.85% in average. Inlet structure, intake, 5 cubic meters per second. The casing has a length of 75 meters and a height of 2.5 meters above the riverbed. Solid screening. The solid screening is composed by 2 separate chambers, each of which has its own cleansing gate. This allows the discharge of the solids accumulated downriver in the dissipation pond. The individual operation of the gates allows the plant to independently take out of service either one or both tanks for maintenance operations. Transfer piping from the intake to the water treatment plant. The transfer piping has a total length of 1.5 kilometers and a diameter of 1,400 millimeters. Compensation storage reservoir. This stage is constituted by 2 tanks of a capacity of 100,000 cubic meters each, lined with a high-density polyethylene coating of 1.5 millimeters of thickness. It has a dual purpose, compensation, and primary decantation or flocculation. The compensation function operates to support the plant's operation over a period of 24 hours without requiring inflow of water to the system. The primary decantation takes a period of 24 hours to finish the process, allowing the sediments of the particles in suspension in the water to settle. Treating facility. The design of the facility has been made for a flow of 2.5 cubic meters per second, with the possibility of increasing production to 5 cubic meters per second. The main level for the whole operation is at 321 meters above sea level. The treating process. The height differential of the levels in the different operation process allows gravity to do the work, taking advantage of the downstream, which makes the use of electromechanical equipment unnecessary, which is another advantage in comparison to other water potabilization technologies. The only electrical equipment is for the dosage pumps for the chemical elements and for the pre-chlorination and final disinfection of the treated water. Other electrical power usage is related only to some premises services, such as lighting. The plant's design incorporates the recovery of the filter cleansing water through reprocessing through the treatment chain. The flash blending circuit has an intake and 6 partial channels. The input dosage is automatically regulated from the control room by means of a pin valve. The partial channels are structures that allow the blending of the coagulating and other chemicals, taking the advantage of the hydraulic buildup. Here, the following chemicals are incorporated: the activity of the flocculating agent is the destabilization of the electrical polarity in the particles in suspension, allowing the clotting of the solids in suspension to become bigger and heavier particles, which are named floccules. Separation of clarified water becomes an easier task for the membrane sedimentator. The dosage of the chemicals used in the flocculation are established by means of the Haras test, by which taking raw water samples and in a laboratory procedure simulating the gradients of speed and periods of permanence of the water, the referential doses for application in the plant are established. flocculation units. It has 6 flocculation channels with the corresponding screens working in a vertical flow. Each flocculator has 3 sections with decreasing speed gradients to enhance and secure the growth of the clots. The water flow accesses the channel through a drain and flows alternately, passing through a cross-extended screen and a horizontal screen placed at a specific height above the channel's bottom. By this means, an alternating hydraulic flow is created, allowing a lowering vertical flow to be increased in the next compartment. The hydraulic retention time averages 18 minutes. Screen laminators. 3 tilted screen sedimentation units are in service. Each unit has a row made of corrugated plates. The plates are installed in a 60-degree angle. Each unit has on the lower side lime collection sumps with exit piping for the lime and automated drainage valves for the lime. The latter is transferred by means of a siphon to the lime pit. Gravity filters. The filtering process is aimed at extracting the watery and suspended particles by sifting through a porous filter. The filters have a sifting capacito to the size of 20 microns. Turbidity at the entry stage is of 2 to 3 NTU approximately, and the end product has a turbidity of under 0.4 NTU. The standard establishes the delivery of water with a maximum turbidity of 1 NTU. The cleaning of the filters is by means of a retrowash generated by the cutting of supply from one filter, creating an underpressure in relation of the adjoining cells in the moment the cleansing gate is opened. The generated lack of pressure in the filter allows the pressure of the water of the adjoining cells to enter with a pressure that allows the sand to be moved and the smaller particles contained by the filter to be retrowashed and flooded through the cleansing gate. The water used for the filter washing is recollected in a reservoir which is split into 2 chambers of 1,000 cubic meters, operating independently in order to have maintenance and recirculation independency for each. Chemical storage building. The aluminum sulfate, ferric sulfate, and the polymer pumps operate from this building, as well as the equipment for dosage and production of the polymers. Aluminum sulfate and ferric sulfate. The solution is available in tanks of 50 cubic meters of capacity each. Cationic polymer, delivered in cylinders. Dosage from 0.5 to 0.6 milligrams per liter. Chlorination building. Chlorine stored in a 12.5-ton tank, tanks of 907 kilograms, and bottles of 68 kilograms, as well as the dosification equipment, are in this building. Security equipment. In case of chlorine leaks, the following equipment is available: chlorine leak detectors in chlorine storage room and chlorination chambers. Automatic shut-off valve for the 12.5-ton tank. Air scrubbing towers, caustic soda, and the partial of Raschig rings. Contaminated air extractors for the chlorine deposit and the chlorination chambers. Caustic soda solution storing pit. Leaks protection and a portal crane are in this building. Storage and dosification of chlorine. Chlorine is a disinfecting agent that destroys pathogen agents that are waterborne in a short period of time, which makes it environmentally safe. The dosage used for disinfection is harmless for human health and still bears a residual effect to ensure the water's integrity until it has reached through the distribution net the user, free residual chlorine. Pre-chloration. Average dosage 3 milligrams per liter. Post-chloration. Average dosage 1 milligram per liter. The lime will be stored in drying basins with a capacity of 40,000 cubic meters and lined with HDPE membranes. The basins can be used in an alternated way. Thereby, each basin will rest the lime and thereby isolating the lime from the water and letting the remaining to dry out. A regulating reservoir has the following objectives. It furnishes a reasonable water storage amount for the case that production should have a stoppage and supply must be maintained. It acts as the hydraulic component between water sources, be it upriver or wells dislodging automatically the connection between the distribution network and the supply sources of the plant. The reservoir also ensures that the exposition period of the treated water with chlorine is long enough to ensure an effective disinfection. The laboratory's functions are mainly the following: control, monitoring, and reports of free residual chlorine in the treated water, supervising the adequate use of chemicals, reports on the incoming water analysis and the produced water analysis, pH, turbidity, conductivity, cations, and anions, etc. Reagent and chemical management, as well as the reports on the use of the doses of the flocculating reagents and polymers during the treatment process. It is as well a requirement to stock supply in coordination with the suppliers of the various reagents to ensure a permanent service. It is the laboratory's responsibility to give maintenance, adjustment, calibration, and follow-up on servicing of all the instruments used for its activities. The analysis and testing of the treated water are performed in accordance with the Directiva sobre Desinfección de Agua para Consumo Humano, la Norma Técnica Peruana 214.003 in the copy, and by applicable norms from the WHO, AWWA, or ANSI. The control system retrieves from the various monitoring sensors and gauges placed in the different process stages of the plant, as well as in the various pits, the corresponding information. The analogical or digital readings are retrieved and conglomerated in a PLC. The retrieved information is processed in a network as well as stored in two servers in accordance with the network's architecture, one as a permanent online server and the other as a backup server. This data is filed and processed by a special software named Wonderware, allowing the visualization by means of graphs and reports showing the evoluting trends. The main information fed by the plant's measuring instruments that are fed into the system are flow measurements, pH values, turbidity measurement, free residual chlorine measurement, permanent assessment of the levels in the chemical storage tanks. The sensors will ring an alarm signal when the storage levels are low in the corresponding tank. weighing of the auxiliary chlorine cylinders, chlorine leak detection. The quality and environmental management systems are an adequate scenario for the workers and shareholders of Consorcio Agua Azul to further develop in an efficient and proactive environment, sharing in all its stages harmony, environmental awareness, and generating a proper rate of return for its shareholders.